Well, welcome back. In this chapter, we're going to be talking about PLC installation practices and editing and troubleshooting. So let's go and get into it here. So first of all, PLC enclosures. PLCs are generally mounted within a machine or in a separate enclosure. And so here we're seeing some of the examples of where you could have it for an enclosure box. For most solid-state control devices, a NEMA 12 rated enclosure is recommended. Typically, metal enclosures are used because metal enclosures provide shielding that helps minimize the effects of electromagnetic radiation. The temperature inside the enclosure must not exceed the maximum operating temperature of the controller, typically about 62 degrees C. So PLCs are always mounted horizontally for more efficient heat dissipation. Here's a typical wiring for an AC power distribution with a hardwired master control relay, MCR. For a disconnect switch and transformer, a power disconnect switch is provided so that when required, the PLC can be serviced with the power off. Here's illustration of emergency stop. The switches operate to de-energize the master control relays and remove power to an I/O device. Power to the processor of the PLC remains on, so status lights can continue to provide up-to-date information. What about electrical noise? Electric noise or electromagnetic interference, EMI, is unwanted electrical signals that can disrupt control system circuits. Malfunctions resulting from noise are temporary occurrences of operating errors that can result in hazardous machine operation in certain applications. Radiated noise originates from a source and travels through the air, while conducted noises travels on an actual conductor, such as a power line. The following can reduce the effects of electrical noise: manufacturing design features, proper mounting of the controller, proper equipment grounding, proper routing of wires, and proper suppression added to noise-generating devices. So keep those in mind. Noise suppression is normally needed for inductive loads such as relays, solenoids, and motor starter coils. When inductive loads are switched off, high transient voltages are generated that, if not suppressed, can reach several thousand volts. Proper routing of the power and signal wiring helps to cut down on electrical noise. Use the shortest possible wire runs for I/O signals. Never run signal wires and power wiring in the same conduit. And low-level signal conductors, such as thermal conductors, should be run as shielded twisted pairs and routed separately. Clearly identify each wire to be connected and the terminal to which it is connected. Wiring connectors for input and output modules usually include spaces for labels used for identifying each I/O address and device connected. Okay, in terms of leaky inputs and outputs, electronic devices exhibit a small leakage current even when in the off state, and that may need to be considered when they are connected to the PLC input modules. A common solution is to connect a bleeder resistor in parallel with the input. The resistor acts as an additional lower resistance load, which allows the leakage current to flow through the lower resistance path. A problem can be created when the high impedance load is being controlled. A resistor can be connected across the load to bleed off any off-state leakage current. In terms of grounding, the authoritative source on grounding requirements for PLC installation is the National Electric Code. Manufacturers also provide detailed information on the proper grounding methods to use in an enclosure. A proper installed grounding system provides a low impedance path to earth ground. The complete PLC installation is connected to a single low impedance ground bus. The ground bus is then connected to the building's earth ground. The grounding path must be permanent, that is, no solder, continuous, and able to conduct safely the ground fault current in the system. Ground loops can cause problems by adding or subtracting current or voltages from inside signal devices. In a varying magnetic field passes through one of these ground loops, a voltage is produced and current flows in the loop. not something that you want to have happen. For voltage variations and surges, the power supply section of the PLC system is built to sustain line fluctuations and still allow the system to function within its operating range. If voltage fluctuations exceeds this range, then a system shutdown will occur. In areas where excessive line voltages, variations, or extended brownouts are anticipating, installing a constant voltage transformer may be required to minimize nuance shutdowns of the PLC. Isolation transformers are used to isolate the PLC other equipment connected to the distribution system. The normal practice is to place the PLC power supply and I/O devices on a separate transformer that may also serve as a step-down transformer to reduce the incoming voltage to the desired level. When current in an inductive load is interrupted, a very high voltage spike is generated. This high voltage can be reduced or eliminated through suppression techniques, which absorbs the inductive induced voltage. So here in the picture, we're seeing a diode is connected to suppress the transient in the DC inductive loads. For you can have an RC circuit connected to suppress the AC loads, and so RC is resistor capacitor, and we're seeing that here in the illustration of the schematic there. The metal oxide varistor can also be used to help with surge protection.